we're going to graph linear equations. In order to do that, I'm going to give you an example of a linear equation. A linear equation might look like this. So for example, given, it would be y is 2x plus 1. It involves y and x both to the first power. Or it could look like 3x plus 5y equals 15. Both of these are examples of linear equations. And what we're going to do is we're going to start by graphing them, and then we'll use the concept of slope to let us graph them in a very quick way. To start with, let's graph y equals 2x plus 1. In order to do this, we're going to set up a table of values. To start with, I set up a table. I have x and y. And a nice way to do this is to use consecutive positive and negative numbers. So to start with, I'll let x be 0. So y is 2 times 0 plus 1, which is 1. Then I let x be positive 1. So y is 2 times 1 plus 1. 2 plus 1 is 3. Then I'll let x be negative 1. 2 times negative 1 plus 1. Negative 2 plus 1 is negative 1. Then I'll let x be 2. 2 times 2 plus 1. 4 plus 1 is 5. Let x be negative 2. 2 times negative 2 plus 1. Negative 4 plus 1 is negative 3. So we'll start with those ordered pairs. We'll now proceed to graph this. This first one is the ordered pair 0, 1. And we know that x is the right left and y is the up down. So x being 0, we start at the origin, we don't go anywhere. Y being 1, we go up 1. And that's that ordered pair. Next ordered pair is 1, 3. X is 1, so we go from the origin over 1, right 1, and then up 1, 2, 3. And that gives us the next ordered pair. Here we get negative 1, negative 1. So we start at the origin, x being negative 1, we go left 1, y being negative 1. After we've gone left 1, we go down 1. And we continue with these. 2, 5, we go right 2, up 1, 2, 3, 4, 5. And then finally, negative 2, negative 3. We go left 1, 2, down 1, 2, 3. And we can continue in this way. We're going to connect these dots, and what we have is the graph of the line. So putting the line, this will be the graph of the equation y equals 2x plus 1. From the equation, there's significance for the coefficient of x once we have y as equals something x plus something. This, too, once we have it as y equals, is known as the slope. And so in this particular equation, the slope, we write it as a fraction. It's 2 over 1, and that's going to be an up to over ratio, or I call it an up-down to over ratio. One way to think of it is positive 2 over positive 1, which is up 2 units and right 1 unit. So if we start with any point on this line, the slope would get us to the next point by going up 2, and then over 1. And we get the next point on the line. Another way to think of this also, instead of it being 2 over 1, it could have come from negative 2 over negative 1, which would tell us we would go from any point on the graph down 2, and the negative 1 would tell us we're going left 1. So if we take any point on the graph, if we go down 1, 2, then we would go left 1 to get another point on that graph. And putting these here, you can see the ratio is always 2 units to 1, and that's what the slope means. So we will be able to use it to graph that line. We're going to go to the next page and graph that line just using this concept of slope. We're now going to graph the same line, y equals 2x plus 1, only we're going to graph it with this concept of slope. When it's in this form, y equals something x plus something, the number in front of x is known as the slope, and the number that you're adding, whether it's positive or negative, is known as the y-intercept. It's the y-intercept because we let x be 0, and it gives us the y value. If you let x be 0, you get y equals something times 0 plus b. So it's just 0 plus b, which is b. And that's what we call the y-intercept. We're now going to graph y equals 2x plus 1. We identified that the slope of that line is 2, which we can write as 2 over 1. That's going to be helpful because it's the up to over ratio. The y-intercept for this problem, the y-intercept is going to be 1, which we write as the ordered pair 0, 1. And that's going to be the starting point for us to graph our line. Using the slope from the y-intercept, the slope being 2 over 1, that tells me I go up 2 over right 1, up 2 over right 1, up 2 over right 1. But I also, like we did before, the fact that it's 2 over 1, I could also do negative 2 over negative 1. So I can go down 2, which means then I would go left 1, down 2, left 1, down 2, left 1, down 2, left 1. And once I've done all those, then I'm going to connect the line. So all those ordered points will be connected with a line, and you'll see in a moment. So now I've put the line, and you see that it is the same as the one we got using the table of values. And one thing that I would like for everyone to do is to put ordered pairs next to each point on that line. So in doing that, I see that my starting point was 0, 1. Then this point is 1, and it was up 3 here, so it's 1, 3. This next point was 2, 5, and then this point was negative 1, negative 1. And just putting one more, this point right here is negative 2, negative 3. And I could do that for all the points on the line. But we'll see from looking at this that these are the same ordered pairs as we got from the table.